so that you can become half a repairman. Attention, please. Let's take a look at the transducer box. This is the main wheel. The right side is fixed on the spindle. The left side can be moved. It's called the pulley. This is made up of the drive wheel, the open close plate and the spring. Under the spring, the smallest gap between the two plates allows the belt to be in the maximum straight state and the motorcycle to be in the low-speed high-torque state. There are many pulleys in the pulley plate. When the engine speed starts to increase, the pulleys will be thrown out due to centrifugal force. At the same time, push the pulley plate to shorten the two plates, so that the V-shaped belt is squeezed. Is made up of the drive wheel, the open close plate and the drive plate. The pulley plate is fixed by the spring and tightened inward. When the engine speed increases, under the influence of centrifugal force, the pulley plate is thrown out, the box is closed and the pulleys are driven. When the pulleys are driven, the rear wheels start to move forward, and the power is transmitted. The transducer is much more complicated. The shifter is connected to a shifter shaft. There are different shaped grooves on it that allow the shifter to make specific movements. The gears that the shifter controls are called synchronized gears. Synchronized gears have inner flowers, which can hold the shaft and synchronize the movement, and can move left and right. This is called a free gear. It can rotate freely around the shaft, but it can't move left and right. Use blue to mark all free gears. Finally, this orange one is called a fixed gear, which is fixed to the input shaft. Here's the point. Synchronized gears and free gears can combine with each other. In this way, the free gears can drive the synchronized gears to rotate and output the power to the shaft. Okay, now let's simulate switching gears. As you can see, all synchronized gears and free gears combine with each other at this time. The vehicle is in a state of vacuum. If you combine number 5 with number 1 drives number 5 to rotate, and number 5 drives the output shaft to rotate through the flowers. This is the first gear. Divide number 5 into number 4 and number 2. Number 2 drives number 4 to rotate. Number 4 drives the output shaft to rotate through the flowers. This is the second gear. Divide number 4 into number 3. This is the third gear. In this, different gear ratios, and thus achieve the effect of switching gears. If such a clever structure is placed on a car, it will be the famous series gearbox. Isn't it a little unexpected? Finally, let's look at the clutch of the gearbox. The power generated by the engine is converted by the axis into a rotation movement, and then the power is transmitted to the outer shell of the clutch, and the structure of the clutch is transmitted to the rear wheel through the gearbox. The clutch is made up of multiple parts. The one on the far right is called the clutch plate, and the one in the middle is called the friction plate and the metal plate, and they are arranged alternately. The one on the left, the clutch shell can be freely rotated without the restriction of the gearbox, connecting from the input shaft of the clutch plate to the input shaft of the gearbox, and rotating in the same axis. If there is a gear connector that has gears inside and outside, it can be locked with the clutch shell and the clutch plate, and the power of the engine can reach the gearbox at this time. If it is removed, the power will be cut off. But there will also be a new problem. When removing the connector, the clutch will rotate with the inertia of the rear wheel, and the clutch shell will rotate with the power of the engine. There must be a speed difference between the two. It is obvious that a connector cannot satisfy two speeds at the same time, so the engineer uses a clutch plate to replace this imaginary connector. The clutch plate is made up of a friction plate and a metal plate. The spacer on the friction plate collides with the clutch shell, and it can slide sideways. The spacer on the metal plate is not full, and it can slide sideways when it collides with the clutch plate. When the two plates are connected, the friction force will drive the clutch shell and the clutch plate to rotate together. Even if the speed of rotation of the two plates is different at the beginning, the gradual increase in friction force can also be stable and excessive. The size of the clutch plate friction force is controlled by the clutch plate. When holding the clutch handle tightly, the clutch line pulls the clutch connection rod.